Hi everyone, welcome to section 1 of our word problem series. Today, we'll master division with fractions. We're looking at Module 6, Division and Mixed Arithmetic Operations of Fractions. Unit 9 focuses on word problems. Word problems can be tricky, but the thinking way is to find the relationship between the numbers first. My first know-how tip, always read the question twice to identify what the total and the part are. This is crucial for success. In this unit, we will learn how to tackle problems where we need to share or compare quantities using division. We'll start with simple division and move to fractions. Understanding the unit cost or unit capacity is our primary goal. Think of math as a language. We're translating stories into calculations. Let's start with our first example together. Ready? Keep your notebook handy and let's dive into the preview on page 2. This sets the foundation. Here's our first problem. Each kilogram of red beans costs $8. We want to find out how much we can buy. Question 1 asks, how many kilograms for $24? The thinking way is total money divided by unit price. Know-how, 24 divided by 8 equals 3, so we can buy exactly 3 kilograms. Simple enough, right? Let's go deeper. Question 2 asks for $15. Again, use total money divided by unit price, 15 divided by 8. 15 divided by 8 is 15 over 8 as a fraction. In its simplest mixed number form, that is 1 7/8 kilograms. Why do we use fractions? Because it's more precise than decimals for many division problems. Always keep the remainder. To tackle these, identify your divisor. Here, the $8 is what we are dividing the total by. Every dollar counts. Practice converting these improper fractions into mixed numbers. It makes the answer much easier to understand in real life. Look at page 3. 2 liters of juice fill 8 identical cups. We need the capacity of each cup. What's the plan? The thinking way. We are distributing a total amount into equal groups. Total juice divided by number of cups. 2 divided by 8. We write this as 2 over 8. Notice we can simplify this. Divide both by 2. That gives us 1 over 4 liters. Each cup holds a quarter of a liter. Visualizing this with the diagram helps a lot. Know-how. If the result is less than 1, your answer will be a proper fraction. Always simplify your fractions to the lowest terms. To tackle capacity problems, ensure your units are correct. Here, the answer is required in liters. Stay consistent. Remember, 2 divided by 8 is not the same as 8 divided by 2. The order of division matters immensely in word problems. The diagram shows 2L split into 8 parts. Each part is L. That's exactly what our calculation represents. Perfect. Moving to page 4. 6 bottles contain 1 8/25 liters. This one is a bit more challenging. Ready? Thinking way. We have a mixed number total. To divide by 6, we must convert it to an improper fraction first. 1 times 25 plus 8 equals 33. So we have 33 over 25 liters. Now let's divide that by 6 bottles. Know-how. Dividing by 6 is the same as multiplying by 1 over 6. This is the keep change flip method you need. Simplify before multiplying. 33 and 6 can both be divided by 3. That leaves us with 11 and 2. Much easier. 11 over 25 times 1 over 2 equals 11 over 50 liters. Each bottle holds 11/50ths of a liter of milk. Success! To tackle complex fractions, step by step is best. Don't rush the simplification. Checking your work is key. This problem proves that mixed numbers are just fractions in disguise. Once converted, they follow the same rules. Final example on page 5. Spinach costs $27.50 per kilogram. How many kilograms can we buy for $66? Thinking way, total money divided by price per unit. 66 divided by 27.5. Convert that mixed number first. 27.5 becomes 55 over 2, so we calculate 66 times 2 over 55. Remember to flip the divisor. Simplify by 11. 66 becomes 6, and 55 becomes 5. 6 times 2 over 5 equals 12 over 5, or 2 2/5 kilograms. Always convert your final answer back to a mixed number for weight. It makes more sense than an improper fraction. Great work today. Practice these steps, and I'll see you in section 2 for more math fun. Keep learning. Welcome back to section 2. I'm so glad you're here. Today, we're continuing our journey with fraction word problems, moving from examples to practice. Let's look at page 6. Holman is running on a circular track that's 3/8 of a kilometer long. He has run 5 1/4 kilometers. The thinking way. We want to know how many rounds he's run. This means we're finding how many times the track length fits into his total distance. Total distance divided by track length. That's 5¼ divided by 3/8. Convert that mixed number to an improper fraction first. Know how. 5¼ is 21/4. Now, keep the first fraction, change division to multiplication, and flip 3/8 to 8/3. Simplify. 21 and 3 simplify to 7 and 1. 8 and 4 simplify to 2 and 1. 7 times 2 equals 14 rounds. He's been busy. To tackle circular track problems, always remember, total distance divided by track length equals the number of rounds. Easy! Notice the diagram. It shows the total distance split into rounds of 3/8 kilometer each. Math is just seeing the patterns in the world. Now for consolidation. Page 7, exercise 1. We have 10 identical bags of brown sugar weighing 4 kilos in total. What's the weight of one bag? Thinking way. We're splitting a total weight into 10 equal parts. Total weight divided by number of bags. That's 4 divided by 10. 4 divided by 10 is 4/10. We can simplify this fraction by dividing both numbers by 2. That gives us 2/5 of a kilogram. Know how. When dividing a smaller number by a larger one, your answer will always be a proper fraction. No mixed numbers here. To tackle sharing problems, always put the amount to be shared as the numerator and the number of shares as the denominator. Check your units. The question asks for weight in kilograms, so our answer of 2/5 kilograms is exactly what's needed. Perfect. Imagine these 10 bags on a scale. Together they hit 4 kilo. If you take just one, it's a fraction of that total weight. Makes sense, right? Solid start! These consolidation exercises build your muscle memory. Let's move to the next one on page 8. Get ready! Exercise 2. 3 egg tarts cost $14.1 How much does one tart cost? I love egg tarts, but let's focus on the math. Thinking way. Same logic as before. Total cost divided by quantity. 14.1 divided by 3. Convert that mixed number. 14 times 10 is 140, plus 1 is 141, so we have 141/10. Now we divide by 3, which is multiplying by 1/3. Know how. 141 is divisible by 3 because 1 plus 4 plus 1 is 6. 141 divided by 3 is 47. Our result is 47/10. 47/10 converted back to a mixed number is 4 7/10. Each egg tart costs $4.70. Deliciously simple. To tackle money problems, remember that fractions of a dollar relate directly to cents. 7/10 is like 70 out of 100 cents. Always keep your work organized. Write down the division sentence first, then the conversion, then the final multiplication. No skipping steps. Great progress. We're halfway through our consolidation practice for this section. Let's keep that momentum going. Exercise 3 on page 9. Haley pays $35 for 2 4/5 meters of ribbon. What is the cost per meter? Thinking way. Finding the unit price. Total price divided by total length. 35 divided by 2 4/5. Step 1. Convert. 2 times 5 is 10, plus 4 is 14. 14/5. Our calculation is 35 times 5/14. Always flip that second fraction. Know how. 35 and 14 are both in the 7 times table. 35 becomes 5 and 14 becomes 2. 5 times 5/2 is 25/2. 25/2 is 12.5, so each meter of ribbon costs $12.50. Haley got a fair deal. To tackle ribbon or cloth problems, remember the unit is per meter. Your divisor is the quantity of meters you bought. Check your work by multiplying the unit price back by the length. 12.5 times 2.8 should equal 35. It does. Logic wins again. Only one more exercise to go in this section. You're doing amazingly well. Let's finish strong on page 10. Last one. Exercise 4. A juice shop made 4.5 liters of juice. Each cup takes 3/10 of a liter. How many cups? Thinking way. We're filling cups from a big container. Total juice divided by capacity of 1 cup. 4.5 divided by 3/10. 4.5 becomes 9/2. Now multiply by the reciprocal of 3/10, which is 10/3. Ready to simplify? Know how. 9 and 3 simplify to 3 and 1. 10 and 2 simplify to 5 and 1. 3 times 5 equals 15 cups. Pour me 1. There are 15 cups of apple juice altogether. The shop is ready for customers. See how easy it is when you know the steps? To tackle how many cups problems, your final answer should be a whole number if it fits perfectly. Fractions just mean a partial cup. Review your conversions and simplifications. They are the secret weapons of math mastery. Practice makes perfect, and you're getting there. That's section 2 complete. We've tackled track rounds, sugar bags, egg tarts, ribbons, and juice cups. You're becoming a pro. Join me in section 3, where we'll look at even more challenging examples. Until then, keep thinking and keep learning. Bye. Welcome back to section 3. You're doing a fantastic job. Today, we'll learn how to pack items into bags and master some very important unit conversions. Let's look at page 11. We have 7/8 kg of cocoa powder. We need to put 1/40 kg into each bag. How many bags can we fill? Thinking way. We're taking a total amount and splitting it into small, equal bags. This is division. Total cocoa divided by weight per bag. That's 7/8 divided by 1/40. Remember our rule, multiply by the reciprocal. So 7/8 times 40/1. Know how? Simplify 40 and 8 first. 40 divided by 8 is 5. Now we just have 7 times 5, which equals 35. That's 35 bags. To tackle how many bags problems, use the formula. Total weight divided by unit weight per bag. Always simplify before you multiply. The diagram shows the 7/8 kg being distributed. Seeing the bags helps us understand the goal of our calculation. Great work! Page 12. A bag of sugar weighs 450 grams. How do we express this in kilograms? This is a very useful real-world skill. Thinking way. Kilograms are larger than grams. 1,000 grams equals 1 kilogram. So, to convert g to kg, we divide by 1,000. Our calculation is 450 divided by 1,000. We can write this as the fraction 450 over 1,000. Now let's simplify this fraction step by step. Know how? First, cancel the zeros. That's 45 over 100. Both are divisible by 5. 45 becomes 9, and 100 becomes 20. 9/20 kg. To tackle weight conversion, remember, grams to kilograms divide by 1,000. It's that simple. Keep this rule in your heart. Look at the Analyze and Think box. It shows that 2,000 dri is 2 kilos and 1,000 gran is 1 kilos. This pattern helps you check if your answer makes sense. Consolidation time. Page 13, exercise 1. Jordan has 1 1/5 liters of green tea. He drinks 3/20 liters daily. When will he finish? Thinking way. We're finding how many daily portions are in the total volume. Total tea divided by daily consumption. 1 1/5 divided by 3/20. Step 1. Convert to improper fraction. 1 1/5 is 6/5. Now, multiply by the reciprocal of 3/20, which is 20 over 3. Know how? Simplify. 6 and 3 become 2 and 1. 20 and 5 become 4 and 1. 2 times 4 equals 8 days. He'll be finished in a week and a day. To tackle consumption problems, always remember, total amount divided by daily amount equals the number of days. Consistency is key. Practice these calculations. The more you do it, the faster you'll get at identifying the reciprocal and simplifying before multiplying. Page 14, exercise 2. Jerry is 115 centimeters tall. Let's express his height in meters. It's like the gram conversion, but with length. Thinking way, 100 centimeters equals 1 meter. Since we're going from a smaller unit to a larger one, we divide by 100. Our calculation is 115 divided by 100. Written as a fraction, that's 115 over 100. This is an improper fraction, so let's simplify it. Know how? Divide both by 5. 115 becomes 23, and 100 becomes 20. 23 over 20 is 1 3/20 meters. Jerry is growing up. To tackle length conversion, remember, centimeters to meters divide by 100. Always simplify your fraction to a mixed number for height. Unit conversion is all about knowing the relationship between units. 1,000 for mass, 100 for length. Keep those numbers straight. Look at page 15. We're starting focus 2, solving problems involving fractions. This is where we learn how to compare different groups. Thinking way. In the first part, we're asked, what fraction of the rectangles are purple? We need to count the parts and the whole. There are 4 purple rectangles and 6 rectangles in total. 4 over 6. Simplify that by dividing by 2, and we get 2/3. perfect. Now, question 2. Haley has 10 cats and 5 bunnies. How many times the number of bunnies is the number of cats? This is comparing. Number of cats divided by number of bunnies. 10 divided by 5 equals 2. So, she has twice as many cats as bunnies. Meow. Know-how. In comparison questions, the group being compared to is always your divisor. Here, it was the bunnies. 5 is our divisor. Focus 2 is all about understanding these relationships. We'll explore this much more in the coming exercises. Keep your eyes sharp. Great progress today! We've packed bags, converted mass and length, and started comparing quantities with fractions. You're a math star! Join me in Section 4 as we delve deeper into comparing groups and ratios. Until next time, keep thinking and keep learning. Bye! Welcome back to our Word Problems Masterclass. I'm so excited to start Section 4 with you. Today, we're going to master the art of comparing groups using fractions. Let's turn to page 16. Jerry has 8 fruit candies and 3 milk candies. We need to find how many times the number of milk candies is the number of fruit candies. Thinking way. When we ask how many times, we are comparing a larger group to a smaller one. This is a division problem. Fruit candies divided by milk candies. That's 8 divided by 3. We can write this as the fraction 8 over 3. This is an improper fraction because the numerator is larger than the denominator. Know how? 8 over 3 is equal to 2 and 2/3. So the number of fruit candies is 2 and 2/3 times the number of milk candies. A very precise comparison. To tackle comparison problems, always divide the first group mentioned by the group being compared to. It's all about the order. Imagine Jerry's candies. For every 1 milk candy, there are 2 and 2/3 fruit candies. Seeing the ratio makes the math come alive. Page 17. In a table tennis team, there are 18 members. Among them, 9 are male. What fraction of all members are male? Let's analyze this. Thinking way. We're looking for a part of a whole. The whole is the entire team, and the part is the number of male members. Know-how, use the quantity of the whole as the denominator and the part as the numerator. Denominator is 18, numerator is 9, 9 over 18. 9 over 18 can be simplified. Since 18 is twice 9, we can divide both by 9. That gives us exactly 1/2. Half the team is male. To tackle team problems, clearly identify the total number of members first. That number is the foundation of your fraction. The parrot in the speech bubble gives us a great reminder. Quantity of the whole as denominator, part as numerator. Never forget that rule. Look at page 18. This slide breaks down our table tennis problem visually. We see the 18 members and the 9 male members highlighted. Thinking way, visualizing the ratio. The diagram shows the total length representing 18 members and a segment for the 9 males. It's a perfect visual aid. The fraction is 9 over 18. The arrow points to 9 as the number of male members and 18 as the number of all members. It's so clear. Know-how, always label your fractions in your notebook. Write males next to the 9 and total next to the 18 to avoid confusion. To tackle visual problems, match the numbers from the text to the parts of the diagram. This thinking way makes the calculation obvious. Notice how the diagram uses a bar model. This is a very powerful tool for solving any word problem. We'll use it often in this masterclass. Page 19 gives us the final answer. 1/2 of all members are male members. We've mastered this first Focus 2 problem together. Well done. Thinking way. If 1/2 are male, what fraction are female? Since 1/2 plus 1/2 equals a whole, the other half must be female. Simple, right? Look at the calculation again. 9 divided by 18 equals 1/2. The final sentence, 1/2 of all members are male members, is our complete answer. Know-how. Always write your final answer as a complete sentence. This shows you understand what the number actually represents in the story. To tackle these problems, don't stop at the fraction. Simplify it and then relate it back to the original question for a perfect result. The blue speech bubbles remind us of the key steps. This masterclass is all about these details. Let's keep moving to the next challenge. Last page for today, page 20. In a sports team, there are 21 old members and 14 new members. What fraction are the new members? Thinking way. This problem is a bit more complex. We're given 2 parts, old and new members, but we need the fraction of all members. Step 1. Find the total number of members. 21 plus 14 equals 35. This is our denominator. The part is the new members, which is 14. So the fraction is 14 over 35. Both numbers are in the 7 times table. 14 divided by 7 is 2, and 35 divided by 7 is 5. 2/5. Know how? If the whole isn't given, add the parts together to find it. This is a common trap in word problems. Don't fall for it. To tackle multi-step fraction problems, always find your total first. The bar model in the diagram shows this step-by-step logic perfectly. Look at that diagram one more time. 21 old, 14 new, total 35. New members are 14/35 of the whole. You're getting so good at this. Fantastic work in Section 4. We've compared candies, analyzed team ratios, and learned how to find the whole when it's hidden. Join me in Section 5 as we continue our word problems masterclass. Until next time, keep thinking and keep learning. Bye for now. Hi everyone. Welcome to Section 5 of our masterclass. Today, we're taking our team fraction problems to the next level with some clever alternative calculation methods. Let's look at page 21. We're continuing with our sports team problem. We have 21 old members and 14 new members. We need to find the fraction of new members. Thinking way. Remember, the whole is the most important part. We must combine the old and new members to find the total number of people on the team. Number of all members is our big question mark here. The diagram shows them side by side, 21 and 14. Together, they make the complete bar. Know how? Always double-check your addition before starting the fraction. 21 plus 14 is 35. If this number is wrong, the whole fraction will be wrong. The bar model makes this relationship so clear. The part sits right inside the whole. Let's see how to write the final answer on the next page. Page 22 gives us the fraction, 14 over 35. But we never leave a fraction like that if it can be smaller. Let's simplify it together. Thinking way, ask yourself, what number goes into both 14 and 35? If you know your 7 times table, you'll spot it instantly. 7 is our magic number. 14 divided by 7 is 2. 35 divided by 7 is 5. So, the new members make up 2/5 of the team, a much simpler and cleaner number to work with. Know how? Simplifying a fraction doesn't change its value, it just changes its look. 14/35 and 2/5 represent the exact same portion. To tackle simplification, start with the smallest prime numbers like 2, 3, or 5. If those don't work, try 7. It's often the hidden factor. Final answer. The new members make up 2/5 of all members. Always state the of what part. It makes your answer meaningful and complete. Now, check this out on page 23. We can also calculate this in one single step. This is a great pro tip for your exams. Let's look closely. Thinking way. Instead of calculating the total first, we can write the entire relationship as one big fraction. 14 over the sum of 21 and 14. The denominator becomes 21 plus 14. This shows exactly where the whole comes from. It's the number of new members over the number of all members. Know how? Using this format helps prevent mistakes. You don't have to remember the 35, you just have to add the numbers you already see in the story. To tackle multi-step problems, try combining your steps into one equation. It's faster and often much more accurate. Try it in your next exercise. This one-step method is what real mathematicians use. It keeps the whole story in one place. Master this and you'll be ahead of the class. On page 24, we see the result of our one-step calculation. It leads us back to the same 14 over 35, and then our familiar 2/5. Consistency is key. Thinking way. No matter which path you take, calculating the total first or using the combined fraction, your final simplified result must be the same. 14 over 35 equals 2/5. This confirms that our addition and our simplification were both correct. It's a great way to check your own work. Know how? If you ever get two different answers using two different methods, go back and check your addition first. That's where most mistakes hide. To tackle any math problem, having two ways to solve it is your best defense against errors. It builds your confidence and your skill. We've spent a lot of time on this sports team, but it's worth it. Understanding this part plus part equals whole logic is a major milestone. Well done. Finally, page 25. Let's summarize the one-step method. It's the ultimate know-how for Focus 2. Let's review the final layout of the calculation. Thinking way. See the layout? The numerator is the new members and the denominator is the bracketed addition of all members. It's a math masterpiece. 14 divided by the sum of 21 and 14. This leads to 14 over 35, which simplifies to 2/5. It's so logical when you see it all together. Know-how. The new members make up 2/5 of all members. This sentence is the why behind our math. It gives the number its story back. Focus 2 is all about these relationships. You've now mastered the basic team ratio. You're ready for even bigger challenges in the next section. Take a moment to look at this slide. The blue box highlights the alternative calculation. It's a great reference for your study notes. Keep it handy. Fantastic progress in Section 5. We've mastered 2 different ways to solve team ratio problems and learned the importance of the whole. Join me in Section 6, where we'll apply these skills to books and fruit plates. Until then, keep thinking and keep learning. Goodbye. Welcome back to Section 6 of our masterclass. I'm so proud of the progress you're making. Today, we're putting our skills to work with some delicious and educational examples. Let's turn to page 26. Haley read 16 books this term, and 4 of them were math books. What fraction of all the books she read were math books? Thinking way. We're finding a part of a whole. The whole is the 16 books Haley read, and the part is the 4 math books. Simple division. Our fraction is 4 over 16. We always look to simplify. Both 4 and 16 are in the 4 times table. 4 divided by 4 is 1, and 16 divided by 4 is 4. Know-how. 1/4 of all books Haley read were math books. Tip. Always keep the units in mind. Here, the all books is our reference point. To tackle these, write your fraction first, then simplify. It makes the answer much clearer. Math is all about seeing the simple part inside the complex. Think of it like a pizza cut into 16 slices. If 4 slices are math, that's exactly 1/4 of the whole pizza. Perfect visualization. Page 27. We have a plate with 9 apples and 15 oranges. What fraction is the number of oranges of the total number of fruit on the plate? Thinking way. First, we must find the total. 9 apples plus 15 oranges equals 24 pieces of fruit. That's our denominator for the whole. The fraction of oranges is 15 over 24. Let's simplify. Both 15 and 24 are in the 3 times table. 15 divided by 3 is 5. 24 divided by 3 is 8. Know-how. The number of oranges is 5/8 of all fruit. Tip. Whenever the question says, of that of all, you know you must add all items first. To tackle mixed group problems, find the whole as your very first step. It's the most common place where students make mistakes. Look at the diagram. 15 over the sum of 9 and 15. This confirms our whole is 24. You're getting very good at spotting these patterns. Now, page 28. We have 6 mangoes and 9 pears. Question 3a. What fraction of the number of pears is the number of mangoes? This is different. Thinking way. Here, we aren't comparing to the total. We are comparing mangoes to pears. This means pears are our unit for comparison. The number of pears is our denominator. Mangoes are 6, pears are 9. So the fraction is 6 over 9. See how the pears sit at the bottom? Know-how. The group that comes after fraction of the is usually your denominator. Pears followed that phrase, so 9 goes on the bottom. To tackle these, ignore the total if the question doesn't ask for it. Focus strictly on the 2 groups being compared. Order is everything. The blue box is a golden rule. The number of pears is the unit for comparison. Write the number of pears as denominator. Memorize this. Page 29 shows the solution. 6 over 9 simplifies to 2/3. But there's a new word here, ratio. Let's explore what that means. Thinking way. A ratio is just another way to show a comparison between numbers. We can say the ratio of mangoes to pears is 2 to 3. The fraction 2/3 and the ratio 2 to 3 tell the same story. One uses a division line, the other uses the word 2. They are best friends in math. Know-how. The number of mangoes is 2/3 of the number of pears. This sentence is your final answer. It ties the math back to the fruit. To tackle ratio problems, always simplify your fraction first. The simplest ratio is usually what's expected in your final answer. 2 to 3 is easy. Look at the bottom of the slide. We can also say that the ratio is 2 to 3 ows. This connection between fractions and ratios is vital. Master it. Finally, page 30. Our parrot friend is back with a summary. We use ratios to compare numbers and express the result as a fraction. Thinking way. This is the master key for section 6. Fractions are ratios and ratios are fractions. They are two ways of saying the same thing. When you see a fruit basket or a group of toys, you can now describe them using these tools. How many more? What fraction of? You're a pro! Know-how. Ratios don't always compare a part to a whole. They can compare two different parts, like mangoes and pears. Stay alert to that difference. This concludes our study of the mango and pear relationship. You've learned how to identify the unit for comparison and how to write a ratio. Great job! Take a final look at our parrot friend's advice. We can use a ratio to show the result of comparing two numbers. Simple, clear, and powerful. What a productive session! We've tackled books, fruit plates, and mastered the concept of ratios and fractions as comparison tools. Join me in section 7 as we flip the script and compare pears to mangoes. Until then, keep thinking and keep learning. Bye for now. Welcome back to section 7 of our Word Problems Masterclass. Today, we're flipping the script on ratios and comparing different measurements like weight and length. Let's look at page 31. We're still with our 6 mangoes and 9 pears, but the question has flipped. How many times the number of mangoes is the number of pears? Thinking way. Since we're comparing pears to mangoes, the mangoes now become our unit for comparison. This means the number of mangoes is our denominator. The number of pears is 9 and mangoes is 6, so the calculation is 9 divided by 6. Notice how the larger number is now the numerator. Know how? 9 over 6 can be written as 9 divided by 6. This is our bridge between fractions and division. The order of words in the question determines the order of numbers. To tackle flipped ratios, always re-identify your unit for comparison first. Just because we saw mangoes first earlier doesn't mean they're always the part. Look at the dashed box. It reminds us that 9 over 6 is the same as 9 divided by 6. This is a vital concept for the rest of this unit. Let's see the result. On page 32, we find the answer. 9 over 6 simplifies to 3 over 2. We divide both numbers by 3. But wait, that's an improper fraction. Thinking way. 3 halves is equal to 1 and 1/2. This means the number of pears is 1.5 times the number of mangoes. It makes sense, right? The number of pears is 9, mangoes is 6. 9 is definitely larger, so our answer should be greater than 1. 1.5 is exactly right. Know how? When your numerator is larger than your denominator, your result will be how many times larger the first group is. It's a scale factor. To tackle how many times questions, expect an improper fraction or a mixed number as your final answer. It shows the relationship clearly. The final sentence confirms it. The number of pears is 1 and 1/2 times the number of mangoes. You've now mastered comparing in both directions. Page 33. We're connecting everything. We can also say the ratio of pears to mangoes is 3 to 2. This can be shown as the fraction 3 over 2. Thinking way. Ratios aren't just for small parts of a whole. They can show that one group is 1.5 times the size of another. 3 to 2 is exactly that. Look at the dashed box. It says, when a fraction is greater than 1, it is usually expressed as an improper fraction. This is very common in ratios. Know how? Ratio 3 to 2 means for every 2 mangoes, there are 3 pears. It's a simple recipe for our fruit basket. Fractions make it easy to see. To tackle advanced ratios, don't be afraid of improper fractions. They are the standard way to show a larger to smaller relationship. 3 over 2 is perfect. We've spent 15 slides on fruit, and you're now a ratio expert. Let's apply these skills to something else, human weight. Ready? Page 34. The teacher weighs 70 kilos and Haley weighs 35 kilos. Question 4a. What is the ratio of the teacher's weight to Haley's weight? Thinking way. Teacher is 70, Haley is 35. Since the teacher is mentioned first, 70 goes on top. Haley is our unit for comparison, so 35 goes on the bottom. 70 over 35. Wait a minute, 70 is exactly twice 35. So the fraction simplifies to 2 over 1. This is a very strong relationship. Know how? A ratio of 2 to 1 means one is twice as heavy as the other. We often write it as just 2, but the 2-1 part is always hidden inside. To tackle weight problems, check if one number is a multiple of the other. 35 times 2 is 70. Identifying this makes the ratio instant. The ratio of teacher's weight to Haley's weight is 2 to 1. This means the teacher weighs exactly as much as 2 Haleys. That's a lot of Haley. Page 35 flips it. Question 4b. What is the ratio of Haley's weight to the teacher's weight? Now Haley is on top. Ready? Thinking way. Haley is 35. Teacher is 70. Since Haley is mentioned first, 35 is our numerator. The teacher is now our unit for comparison. 70 is the denominator. 35 over 70. We simplify by dividing both by 35. That gives us 1 over 2. This is the exact reciprocal of our previous answer. 1/2. Know how. The ratio of Haley's weight to the teacher's weight is 1 to 2. This shows that Haley is half the weight of her teacher. Simple and clear. To tackle these double questions, always compare your results. If one ratio is 2 to 1, the flipped ratio must be 1 to 2. Use this to check your work. The bar model isn't here, but you can imagine it. 35 is half of 70. Seeing these numbers as pieces of each other is the secret to ratio mastery. Well done! Fantastic work in Section 7. We've mastered improper fractions and ratios and learned how flipping the comparison flips the whole calculation. Join me in Section 8 as we look at even more ways to express these relationships. Until then, keep thinking and keep learning. Bye for now. Welcome back to Section 8. You're doing incredible work. Today, we'll finish our weight discussion and then dive into measuring the capacity of different containers using our ratio skills. Let's review page 36. We summarize the relationship between the teacher's weight and Haley's weight. The teacher is 2 times Haley's weight. That's a 2 to 1 ratio. Thinking way. Whenever one thing is a certain number of times another, the relationship is a two-way street. If A is twice B, then B must be a fraction of A. Since the teacher is twice as heavy, Haley's weight is 1/2 of the teacher's weight. See how the numbers 2 and 1/2 are linked? They are reciprocals. Know how. Master this reciprocal relationship. It allows you to switch your unit for comparison instantly. Half the weight means twice the other weight. Simple and elegant. To tackle these, identify the whole number first, the times part, then flip it to find the fraction. It's a mental shortcut that works every single time. The speech bubble at the bottom is our key. The teacher's weight is 2 times Haley's weight. Haley's weight is 1/2 of the teacher's weight. Perfect summary. Page 37. Now we're looking at capacities. A bottle holds 1/2 liter and a flask holds 3/8 of a liter. Question 5a. How many times the flask is the bottle? Thinking way. We are comparing the bottle to the flask. This means the flask is our unit for comparison. So 1/2 divided by 3/8. Let's do it. 1/2 times 8 over 3. Remember to flip that second fraction. Simplify 8 and 2. 8 divided by 2 is 4. Now we have 4 over 3. Time to convert. Know how. 4 over 3 is 1 1/3. So the capacity of the bottle is 1 1/3 times the capacity of the flask. The bottle is definitely bigger. To tackle fraction division in ratios, always simplify before the final step. It keeps your numbers manageable and prevents big calculation errors. The result 1 1/3 shows exactly how much more the bottle can hold compared to the flask. You're doing great with these complex fractions. Flip it on page 38. Question 5b. What fraction of the capacity of the bottle is the capacity of the flask? Now the bottle is our denominator. Ready? Thinking way. 3/8 divided by 1/2. We're finding what portion the smaller flask occupies within the larger bottle's capacity. Think small into big. 3/8 times 2 over 1. Simplify the 8 and the 2. 8 becomes 4 and 2 becomes 1. 3 over 4 is our final fraction. 3/4. That's almost a whole bottle. Know how. The blue box is our guide. Capacity of flask divided by capacity of bottle. This formula is the secret to getting every comparison question right. To tackle these, double-check which container is the unit for comparison. It's always the one after the word of. In this case, it was the bottle. The capacity of the flask is 3/4 of the bottle. We've mastered the two-way comparison again. You're becoming a true ratio master. Page 39 summarizes our bottle and flask findings. We can say the ratio of the bottle to the flask is 4 to 3, or the flask to the bottle is 3 to 4. Thinking way: 1 and 1/3 times is the same as the ratio 4 to 3, and 3/4 is the same as the ratio 3 to 4. Ratios and fractions are siblings. Look at the fractions 4 over 3 and 3 over 4. Notice anything? They are flipped versions of each other. This symmetry is the beauty of math. Know-how: the order of names in your ratio must match the order of your numbers. Bottle to flask is 4 to 3. Flask to bottle is 3 to 4. Don't mix them up. To tackle ratios, always write out the words first. Bottle, flask. 4, 3. This simple step prevents the number flipping error that catches so many. You've now seen how ratios apply to weight and capacity. The logic is identical. Math is a set of universal tools you can use anywhere. Finally, page 40. Our parrot friend helps us conclude everything. If A is 2 times B, then B is 1/2 of A. This is the golden rule of comparison. Thinking way: this is the generalization. It applies to any numbers, not just weight or capacity. If C is 4/3 times D, then D is 3/4 of C. See the pattern? You just flip the fraction to find the reverse relationship. 4 over 3 becomes 3 over 4. It's like magic, but it's just math. Know-how: mastering these reciprocals is the ultimate thinking way. It gives you total control over how you describe the world around you. You're a pro! This section was a big step up, and you handled it perfectly. Take a moment to let these golden rules sink in. They are your new best friends. The Parrot Summary is your study guide. Keep it close, and you'll never be confused by a how many times question again. Fantastic job today. What an enlightening session. We've mastered the reciprocal relationship between times larger and fraction of. You've truly leveled up. Join me in Section 9 as we put all these rules to the test with some consolidation exercises. Until then, keep thinking and keep learning. Bye. Welcome back to Section 9 of our Word Problems Masterclass. Today, we're moving from weights and capacities to comparing shapes and lengths. Let's get our geometry hats on. Look at page 41. We have 6 squares and 10 circles. Question 1a asks, what is the ratio of the number of squares to the number of circles? Thinking way: since squares are mentioned first, they are our numerator. Circles are our unit for comparison, so they go on the bottom. 6 over 10. 6 over 10 can be simplified by dividing both by 2. That gives us 3 over 5. The ratio is 3 to 5. It's a very clean comparison. Know-how: ratios aren't just for numbers. They describe the visual balance between different items. For every 3 squares, there are 5 circles here. To tackle shape ratios, always count your items carefully twice. One small counting error can lead to a wrong ratio. Accuracy is key. The final sentence confirms it. The ratio of the number of squares to the number of circles is 3 to 5. Great start to Section 9. Flip it on page 42. Question 1b. What is the ratio of the number of circles to the number of squares? Now the circles take the lead. Ready? Thinking way: circles first, so 10 is on top. Squares are our comparison unit, so 6 is the denominator. Our fraction is 10 over 6. Flip that logic. Divide both by 2 again. 10 becomes 5 and 6 becomes 3. 5 over 3. This is an improper fraction, showing circles are more numerous. Know-how: the ratio is 5 to 3. Notice how it's the exact reciprocal of our previous answer. When the items flip, the numbers flip too. To tackle flipped questions, always reread the order. Don't assume it's the same as the last slide. Math rewards the careful reader. Final answer: the ratio is 5 to 3. You've now mastered the two-way relationship between squares and circles. Let's move to something colorful. Page 43. We have a blue string, 5 1/5 meters, and a purple string, 1 3/10 meters. How many times is the blue string the purple one? Thinking way: comparison again. Blue divided by purple. 5 1/5 divided by 1 3/10. Mixed numbers mean conversion first. 5 1/5 is 26/5. 1 3/10 is 13/10. So we calculate 26/5 times 10 over 13. Remember to flip. Know-how: simplify. 26 and 13 become 2 and 1. 10 and 5 become 2 and 1. 2 times 2 equals 4. The blue string is 4 times as long. To tackle string problems, convert both to improper fractions immediately. It clears the path for easy simplification and multiplication. Seeing that 4 feels good, doesn't it? It means for every purple string, you can fit 4 blue strings end to end. What a difference! Page 44. What fraction of the blue string is the purple string? We already know the answer from our golden rule, but let's prove it. Thinking way, since the blue string was 4 times the purple must be 1/4 of the blue. Flipping is the name of the game. We've practiced this logic before. If A is 4 times B, then B is 1/4 of A. It's a symmetry that makes math so predictable and fun. Know how? You can answer this without calculating. Just take your previous result, 4, and flip it to get 1/4. It's a major time saver. To tackle these double questions, use your first answer to predict the second. It's the best way to double-check your own work. The final fraction is 1/4. We've mastered the relationship between these two strings. Now let's cut some cloth. Ready? Page 45, exercise 9. A piece of cloth 21 meters long is cut equally into 6 sections. How long is each section? Let's figure it out. Thinking way, we're taking a long length and sharing it into 6 equal parts. This is a division story. Total length divided by number of sections. 21 divided by 6. We can write this as 21 over 6. Both numbers are divisible by 3. 21 becomes 7 and 6 becomes 2, 7 halves. Know how? 7 halves is 3 1/2. So each section of the cloth is 3.5 meters long. That's a lot of sewing material. To tackle cutting problems, ensure your divisor is the number of pieces. Your answer will be the length per piece. Keep your units clear. The final sentence confirms. Each section of the cloth is 3.5 meters long. We've started exercise 9 with a perfect win. What a great session! We've compared shapes, masterfully flipped string ratios, and solved our first exercise 9 word problem. You're unstoppable! Join me in section 10 as we continue through exercise 9 with pea shoots and bottle capacities. Until then, keep learning and keep thinking. Bye. Welcome back to section 10 of our word problems masterclass. You're doing incredible work. Today, we're going to use our division skills to solve real-world problems about shopping and measurements. Let's look at page 46. Exercise 2. Pea shoots cost $21 per kilogram. Mom pays $15 3/4. How many kilograms did she buy? Thinking way, we need to find the quantity. That's the total price divided by the unit price. So 15 3/4 divided by 21. Step 1. Convert to an improper fraction. 15 3/4 is 63 over 4. Now multiply by the reciprocal of 21, which is 1 over 21. Know how? Simplify 63 and 21. 63 divided by 21 is exactly 3. Now we have 3 over 4. She bought 3/4 of a kilogram. To tackle pricing problems, identify your unit price first. That's your divisor. Your answer will be the weight or number of items. Clear and logical. Mom made a great choice. Pea shoots are delicious. Remember to always simplify your fractions to make the answer easy to read. Let's move on. Page 47, exercise 3. A bottle has a capacity of 650 milliliters. Let's express this in liters. Units matter a lot in science and cooking. Thinking way, 1,000 milliliters equals 1 liter. Since milliliters are smaller, we divide the number of ml by 1,000 to get liters. 650 divided by 1,000. Write it as a fraction. 650 over 1,000. Start by canceling the zeros. That leaves us with 65 over 100. Both end in 5 or 0, so we use the 5 times table. Know how? 65 divided by 5 is 13. 100 divided by 5 is 20. Our final answer is 13/20ths of a liter. A very professional way to express volume. To tackle volume conversions, remember the magic number 1,000. Small to big, divide. Big to small, multiply. Keep that compass straight. The calculation shows 650 over 1,000 simplifies down perfectly. You're becoming a unit conversion expert. Let's check out a rectangular platform next. Page 48, exercise 4. We have a rectangular lecture platform with an area of 36 3/10 square meters. The width is 4 2/5 meters. What's the length? Thinking way. Area equals length times width. So if we have the area and the width, we divide. Length equals area divided by width. 36 and 3/10 divided by 4 and 2/5. Convert them. 306 3/10 divided by 22 fifths. Now multiply by the reciprocal. 363 tenths times 5 over 22. Know how. Simplify. 5 and 10 become 1 and 2. 363 and 22 are both divisible by 11. 363 becomes 33, and 22 becomes 2. 33 over 4. 33 over 4 is 8 and 1/4 meters. The platform is long enough for a great presentation. Checking with multiplication confirms our logic. To tackle area problems, remember the relationship between the three variables. If you're missing a side, division is your best friend. Draw it out. Page 49, Exercise 5. Jerry needs soy milk. At Store A, 4 cartons cost $14 and 2/5. Let's find the price of just 1 carton. Thinking way. Unit price equals total price divided by quantity. So 14 and 2/5 divided by 4 cartons. Convert that mixed number first. 14 times 5 is 70, plus 2 is 72. 72 fifths times 1/4. Simplify 72 and 4. 72 divided by 4 is 18. Now we have 18 over 5. Easy! Know how. 18 over 5 is 3 and 3/5 per carton. This is our baseline price. Store A is ready. But what about Store B? Let's check. To tackle comparison shopping, always find the price per unit. It's the only fair way to compare different bundle sizes. Knowledge is power. Page 50. At Store B, 3 cartons cost $10 and 1/2. Let's calculate the unit price here to see if it's a better deal. Ready? Thinking way. Total price divided by quantity. 10 and 1/2 divided by 3. Convert 10 and 1/2 to 21 halves. Now multiply by 1/3. Simplify 21 and 3. 21 divided by 3 is 7. That leaves us with 7 over 2. In its mixed number form, that is $3 and 1/2. Interesting. Know how. 3 and 1/2 is the same as $3.50. Store B is $3.50 per carton. Now we have 2 prices to compare. Let's finish. To tackle multi-store problems, keep your work organized in 2 columns. Label them Store A and Store B. It prevents mixing up your results. Page 51. The final showdown. Store A was 3 and 3/5 per carton. Store B was 3 and 1/2. Which is less? We need to compare them. Thinking way. 3 and 1/2 is the same as 3 and 5/10. 3 and 3/5 is the same as 3 and 6/10. 5/10 is smaller than 6/10. Since 3 and 1/2 is less than 3 and 3/5, Jerry should shop at Store B. He saves 1/10 of a dollar on every carton. Smart shopping. To tackle comparisons between fractions, give them a common denominator. 10 is the perfect common denominator for 2 and 5. It makes the answer clear. Jerry is happy, and his wallet is happy too. You've solved a very complex multi-slide problem. Give yourself a big pat on the back. Mastery. Fantastic work in Section 10. We've tackled pricing, volume, area, and smart shopping comparisons. You're using math to master the real world. Join me in Section 11 as we move into more complex group analysis and team fractions. Until then, keep thinking and keep learning. Bye for now. Welcome back to Section 11. We are at the home stretch of this booklet. Today, we'll finish our word problems by looking at groups, collections, and some heavy melons. Let's get started. Let's turn to page 52, Exercise 6. In a computer club, there are 26 members. Among them, 14 are boys. What fraction of all members are girls? Thinking way. We aren't given the number of girls directly. We must subtract the boys from the total members to find our part. Total minus boys equals girls. 26 minus 14 equals 12. So there are 12 girls. Now we can write our fraction. 12 girls over 26 total members. 12 over 26. Ready to simplify? Know how. Divide both by 2. 12 becomes 6 and 26 becomes 13. Our fraction is 6/13. 6/13 of all members are girls. Perfect. To tackle hidden groups, always identify the complement group first. Subtracting from the total is a fundamental math tool. Always verify your whole denominator. Look at the calculation layout. It shows 26/14 over 26. This one-step method we learned in Section 5 works perfectly here too. Great application. Page 53, Exercise 7. There are 42 cards. 8 are blue and 9 are green. What fraction of all cards are green cards? Focus on the green. Thinking way. The whole is 42. The part we care about is the green cards, which is 9. The blue cards are just extra information we can ignore for this question. Our fraction is 9 over 42. Both numbers are in the 3 times table. 9 divided by 3 is 3, and 42 divided by 3 is 14. 3/14. Simple. Know-how. 3/14 of all cards are green cards. Tip: word problems often contain distractor numbers like the 8 blue cards. Stay focused on what is asked. To tackle mixed collections, highlight the specific part mentioned in the question. It helps you pick the right numerator every single time. Accuracy matters. The calculation 9 over 42 simplifies beautifully. You're getting so fast at identifying these common factors. Let's move to Jerry's Candies next. Page 54, Exercise 8A. We have 36 fruit candies and 27 milk candies. What is the ratio of fruit candies to milk candies? Sweet problem. Thinking way. Fruit first, so 36 is the numerator. Milk is our unit for comparison, so 27 is the denominator. Our fraction is 36 over 27. Let's simplify. Both are in the 9 times table. 36 divided by 9 is 4. 27 divided by 9 is 3. 4 over 3. The ratio is 4 to 3. This improper fraction shows more fruit. Know-how. The ratio of fruit candies to milk candies is 4 to 3. This means for every 3 milk candies, Jerry has 4 fruit ones. A great balance. To tackle larger numbers and ratios, look for the greatest common factor. Using 9 instead of dividing by 3 twice saved us a lot of time. Efficiency is key. Remember, 4 to 3 is our simplified ratio. It's the golden answer for this problem. But what if we flip it? Let's check page 55. Page 55 flips it. Exercise 8B. What is the ratio of milk candies to fruit candies? Now, milk is our numerator. You can probably guess the answer. Thinking way. Milk candies, 27, divided by fruit candies, 36. 27 over 36. We use our 9 times table again to simplify this fraction. Ready? 27 divided by 9 is 3. 36 divided by 9 is 4. 3 over 4. The ratio is 3 to 4. It's the perfect reciprocal of our 4 to 3 answer from before. Know-how. The ratio of milk to fruit is 3 to 4. Tip: always keep your previous results in mind. Flipping the names flips the numbers. Symmetry is your check. To tackle multi-part questions, always look for the relationship between Part A and Part B. It builds your math intuition and prevents silly mistakes. We've conquered the candy shop. Ratios are now your second language. Let's use them for one final comparison. The Great Melon Debate. Ready? Page 56, Exercise 9A. A hammy melon weighs 1 1/2 kilo, and a watermelon weighs 2 1/4 kilos. What fraction of the watermelon is the hammy melon? Thinking way. Hammy melon divided by watermelon. 1 1/2 divided by 2 1/4. Step 1. Convert both mixed numbers to improper fractions. 1 1/2 is 3 halves. 2 1/4 is 9/4. So we calculate 3 halves times 4 over 9. Simplify 3 and 9, then 4 and 2. Easy math. Know-how. 1/2 times 2/3 equals 2/3. The weight of the hammy melon is 2/3 of the weight of the watermelon. Heavy math simplified. To tackle complex fraction ratios, take it slow. Conversion, flip, simplify, multiply. These 4 steps are your roadmap to a perfect score. The hammy melon is lighter, so it's a fraction of the heavier watermelon. 2/3 makes total sense. Now for the very last slide of our booklet. Page 57, our grand finale. Question 9B. How many times the weight of the hammy melon is the weight of the watermelon? The final flip. Thinking way. Watermelon 2.25 divided by hammy melon 1.5. Since we know the previous answer was 2/3, we can predict this will be 3 halves. Let's prove it. 9/4 divided by 3 halves. That's 9/4 times 2/3. Simplify. 9 and 3 become 3 and 1. 2 and 4 become 1 and 2. 3 over 2. Amazing. Know-how. 3 over 2 is 1 1/2. The weight of the watermelon is 1 1/2 times the weight of the hammy melon. You've done it! Masterclass complete! To tackle the final questions of any unit, use every trick you've learned. Reciprocals, simplifications, and thinking ways. You're a math pro now. Look at the result. 1 1/2. It's the perfect counterpart to 2/3. You've officially mastered the core of Focus 2. Huge congratulations! We've finished our first 11 sections. We've mastered fractions and ratios across team members, collections, and heavy fruit. I'm so proud of your hard work. Join me in Section 12, where we start a brand new adventure in mathematics. Until then, keep thinking and keep learning. Goodbye for now. Welcome back to Section 12 of our Word Problems Masterclass. Today is a special day. We are doing a grand review of everything we've learned so far. We've solved dozens of problems together. Today, we're going to distill all that hard work into 4 essential master rules that you can take into any exam. Let's go all the way back to the beginning. Module 6 was all about division and mixed arithmetic operations of fractions. Sounds complex, right? But our thinking way made it simple. We learned that every word problem is just a story about sharing, grouping, or comparing. Master rule number 1. Sharing means dividing. Let's look back at our juice cup problem on page 3. This was our foundation. When you have a total amount, like 2 liters of juice, and you need to share it equally into cups, your calculation is always total divided by groups. 2 divided by 8 gave us the fraction 2/8. The biggest takeaway here was learning to read fractions as division problems. They are the same thing. And our golden habit, always simplify. 2/8 becomes 1/4. Getting into the habit of simplifying early saves you from huge calculation headaches later. Look at the diagram again. Visualizing the total bar split into smaller question mark segments is a strategy you should use whenever you feel stuck. Master rule number 2. Identify the part and the whole. The table tennis problem on page 18 was the perfect example of this vital concept. When a question asks, what fraction of all members are male? The phrase all members is the whole. The male members is the part. The whole always goes on the bottom as the denominator. The part always goes on top as the numerator. 9/18. It's a structural rule of math. Sometimes the whole is hidden. If they only told us there were 9 boys and 9 girls, we would have to add them together first to find the denominator of 18. So, rule 2 is part over whole. Always verify your denominator before you start simplifying. If the denominator is wrong, the entire answer fails. Master rule number 3. Ratios are just fractions in disguise. Let's revisit our favorite fruit basket on page 29 with the mangoes and pears. A ratio compares 2 different parts directly. The ratio of mangoes to pears is 6:9. We don't even need the total number of fruits here. The most critical part of a ratio is the order of the words. Mangoes came first, so 6 is the numerator. Pears came second, so 9 is the denominator. 6/9 simplifies to 2/3. We write it as the fraction 2/3, or say the ratio is 2:3. They mean the exact same mathematical relationship. So, rule 3 is, in a ratio, the first item is the numerator, the second item is the denominator. Read the question carefully to get the order right. Finally, master rule number 4. The golden rule of reciprocals. Our parrot friend on page 40 gave us the ultimate cheat code for math tests. If item A is a certain fraction of item B, then item B is the flipped fraction of item A. If A is 2 times B, B is 1/2 of A. This works for everything. If the string is 4 times longer, the other string is 1/4. If C is 4/3 times D, D is 3/4 of C. This is the symmetry of mathematics. When you flip the subjects you are comparing, you simply flip the numerator and the denominator of your answer. Rule 4 saves you from doing the calculation twice. If you have a 2-part question, solve the first part, then flip the fraction for the second part. It's brilliant! And there you have it. 4 master rules. Share by dividing, part over whole, ratios follow word order, and flip for reverse comparisons. Keep these 4 rules in your notebook. Next time, in Section 13, we'll start a completely new topic. I can't wait to see you there. Bye for now.